Welcome, everyone, to another episode of Heat Treat Radio. I'm your host, Doug Glenn. I'm also the publisher of Heat Treat Today. You can find out more about Heat Treat Today at www.heattreattoday.com. And I am very privileged to have with me today Dennis Beauchesne from ECM USA. And we're going to be talking about a pretty interesting topic. Actually, it seems to be a growing category of equipment type, and that's modular heat treat systems. So first off, Dennis, welcome.
Thank you. Thank you. It's my pleasure as well, and my honor to be in this interview with you.
Yeah.
Thank you so much.
You're getting used to it now. This is probably our second or third, which is great. So where exactly are you? I see you're out in the shop. I know that, and the offices are torn apart, so you told me. But tell me about this Synergy Center.
Yeah, so I'm standing here in the middle of our Synergy Center. It's about a 5,000 square foot facility that is dedicated to proving out customers' parts for testing various processes, mostly LPC, but we also do a number of other processes here. We have a full metallurgical lab, 3D microscope, a number of tools, including a CMM that we can do before and after heat treatment distortion testing for customers that want to know how much their parts move. So it's a dedicated center just for customers to use. We do use them for pre-completion of installations and final tests, and also training. So there's a lot of training with maintenance training, and as well understanding the software and how everything works together.
Yeah, that's good. So it's proof of process plus much more. You know, you can help customers proof of process, and that's good.
Absolutely. That's a big part of convincing people that this process is for them and it works on their part. We can send them 10 different reports of an exact same material and part, but they want to know what their part will do.
So right.
Seeing is always the same.
Seeing is believing, right? They get in there and see it, so that's good. That's
right.
Nice. That's a nice spot. Anyhow, I also want to, before we get into the questions, I also do want to thank our sponsor of this episode, which in fact is ECM USA. We'll talk more about them later on in the episode, but I do want you to know that they are the North American subsidiary of ECM Group out of France. That whole company, leaders in the field of thermal, gas, and atmosphere management. You can find out more about ECM by going to ecm-usa.com. So we'll hear more about them shortly. So, all right, Dennis. So we want to talk about modular heat treating systems. And on a very basic rudimentary level, what is modular heat treating? How does it differ from what might be considered standard/normal heat treating?
Very good question. So basically, a modular heat treat system is one that works together to have more than one furnace working in the same platform. So you may have a shop that has 5 or 6 vacuum furnaces separated. They each have their own door. They each have their own vacuum system. They each have their own electrical supply, maybe quench motors, those types of things. Or you may have a series of batch IQ furnaces for carburizing, and they're one off. So they're individual, independent systems. And what happens in a modular system is you try to utilize those facilities that can be used for multiple heating chambers. So instead of having one vacuum furnace with one set of pumps and one gas quench motor, what we would do is have 3 to 8 heating cells that would be utilizing one quench, depending on the process timing. And that's all done with an internal transfer car and those kinds of things. But we try to utilize one vacuum system, so it's much smaller than you would have for 3 or 4 cells or 8 cells for that matter. And then, of course, if you had oil quenching, or if it's high pressure gas quenching, which is what's dominating right now in the modular heat treat business.
Yeah.
Even if you had one oil quench, you could supply basically 6 batch IQ hot zones to one oil quench. So there's a savings there is huge just by not having 5 other or 6 other quench tanks in front of this system, as well as the floor space, the number of pits you have to dig, those kinds of things. So a lot of savings is what we're after. Cost savings in floor space, and as well as utility savings in utilizing equipment across a number of heating chambers.
Yeah. So this modular approach is basically separate chambers, let's say, right? I mean, basically it's separate chambers that are dedicated to doing whatever that chamber is doing, and they're all in some way interconnected, right? So you don't necessarily do like the standard units. You would do heat up, you would do, any pre-processing, you would do the actual process itself, you would do the cool down, you would do whatever, all in the same chamber. Whereas a modular unit, you're kind of moving from chamber to chamber to do those each of those separate steps. Is that fair? Is that
Yeah, pretty much.
yeah?
It's I kind of refer to as a continuous batch.
Continuous batch, yeah. That's interesting because we were talking before we actually hit the record button. You had your colleague there, Allison D'Angelo, on, and she just got done visiting the boot camp, and we were talking about different types of furnace types. And I said, well, we started talking about continuous vacuum, which of course is almost a misnomer because a vacuum can't be continuous because you have to open it up to get stuff out and you'd break the vacuum. So anyhow, we talked about it basically being a batch, right? A batch furnace
Mm-hmm.
that's continuous, a continuous batch furnace. So
Mm-hmm.
that's interesting. Okay, so next question I've got for you, now that we have the basic understanding of what these modular systems are, why might companies want to move from a standard type heat treating system to more of a modular? Uh, just a couple of reasons, maybe, if you have some.
Yeah, a couple of reasons. A couple of reasons are manpower, for instance. If
Yeah.
you're running 5 or 6 vacuum furnaces, you're going to need a number of people to open the doors, put new loads in, those kinds of things. With a modular system, you only have one entry or one exit area.
Okay.
So you're only going to be loading one load every 15, 20 minutes into that system. And the system's going to take over and control that load going through the system. The other thing is that, especially in a carburizing atmosphere or situation, you can have every load be a different case depth, a different process in each cell, and then the next load that goes in that same cell can be totally different than the one before.
Right.
So, for instance, if you had a batch IQ, you typically use the same carbon potential, and you are typically going to run the next load almost identical to the one before. Whereas in the modular system, each cell can run a different process every load, and that's one couple of the reasons. The other ones are we'll talk about later too, where it's easier to integrate with automation if you
Okay.
are doing capacity increases.
Yeah. How about a throughput comparison between a standard unit and a modular unit?
Well, the throughput comparison is interesting in the way that, especially in vacuum carburizing, and of course that's what we specialize in here with the modular systems. You typically can use a little higher temperature for carburizing and a little higher carbon potential, so you can get about a 30 to 40% gain in your cycle time,
Yeah.
as well as not tie up. That furnace is operating very close to 100% occupancy because
Yeah.
when that load is done, you're moving it out right into the gas quench. The next load comes and goes right into it. So that's really another benefit of the system using modular systems.
Yeah, I mean, yeah. My understanding is you're able to increase your throughput because
Yes.
you hit on it, right? You got basically 100% utilization of the equipment, or at least darn close there too. Whereas you don't necessarily have that in the standard equipment, right?
Right.
How about the other one I was wondering about was the quality of the product coming out. What
Mm.
what about the modular systems? Are they better for that, generally speaking?
Yeah, the quality of the system, the quality of the parts coming out of the system is improved. You're in a vacuum environment, so you're in a very clean environment, especially if we're considering atmosphere and low pressure carburizing.
Yeah.
It's in a vacuum. We typically, as I said, do everything in high pressure gas quenching, but even in oil quenching under vacuum, you're going to come up with a much cleaner part. Also, in low pressure carburizing, the carburizing is much more uniform through a part
Yeah.
because we heat it to temperature under nitrogen. before the part gets to austenitizing temperature to start attracting carbon. So we make sure that the full part, that's the tooth, the root, everything of the part is at temperature before we start adding carbon to the load. And that makes a much more uniform case depth, which makes a stronger part.
Yeah. Since each module, each chamber, let's say, is dedicated toward to doing what it's supposed to do, it seems like the consistency and the reliability of the parts being processed in a modular system have a much better chance of being higher quality because of that. Comment on that?
Yes. Yeah, well, you don't exactly. You don't have six different variable chambers or six different variable systems. You just have to look at monitoring the connection between those and understanding that the vacuum levels are all the same across the levels and across the cells. And of course, each cell can be at a different temperature
Yeah.
and running a different process, but those are consistent across the board. Exactly.
Yeah. So what would be the typical dedicated cells? What would you have? Would you have a preheat, a high heat, a soak chamber? I mean, what would be the typical chambers?
Well, it's depending on the processes.
Right.
In if you, I mean, what they're typically used for and what they're most widely used for is vacuum carburizing.
Okay.
And for pre-oxidation and preheating, we usually use an air oven for that outside of the system.
Okay.
And we'll connect that with an external loader. Before the load goes into the modular system, the load will go through a regular air oven, be heated up to 700 degrees Fahrenheit, 400 degrees C, somewhere in that area, and then the load will be moved in. Now, if you were talking about sintering, those kinds of applications, there is a debind step or a preheat step that would be done in one cell on one of the cells.
Right.
But some of the processes that can be done in a modular system are um, low pressure carburizing, low pressure carbon nitriding. So that's carbon nitriding like you do.
Yep.
FNC, ferritic nitrocarburizing. Nitriding.
Right.
So there's nitriding cell for that now.
Yep.
Debinding and sintering, like we talked about briefly.
Okay.
And as I said, the most, and of course, neutral hardening, that's
Yeah.
one that's pretty easily done. And the one that is most prominent right now is low pressure carburizing,
LPC.
um,
Yeah. Yeah.
LPC, right?
All
And
right.
that is being used all over the world in these systems.
Yeah. Okay, so let's we were talking about advantages and things of that sort, why companies might want to think about using these systems. I got a couple other questions for you on that line. Uh, First, if you don't mind, put yourself in the position of a captive heat treater. Okay, someone who does their own in-house heat treating, which probably means they've got potentially high volume, low variability as far as their workloads. Why a modular unit?
So the modular unit feeds itself to many different advantages. First of all, floor space. So you're going to save a lot of floor space by not having all these furnaces set up separately.
Yeah.
You'll save utilities in the way that you don't have as many vacuum pumps or electrical systems running these furnaces on their own. You're going to have some shared service, some shared utilities in that fashion.
And
Um,
that's just real quick. That's probably also a savings of maintenance and things of that sort, right? Because you've got fewer of those
yeah.
to take care of. Okay, go ahead.
Right. Yeah, it all goes down the line.
Yeah.
Exactly. Anything that you have that's six of, you're going to have much less than that
Yeah.
on a joint system. It might be a little larger than one of them, but there'll be less of them, of course.
Yeah.
So in a vacuum carburizing application in a captive shop, you typically have the quality of the part is very, very important. Cleanliness, of course, as well. The gas quenching lends itself to no oil in your plant, no
Yep.
washers necessary for the after post quench. Of course, there typically a washer before the process goes in, but you don't have to have any wash to get the oil off of the parts. You don't have to reclaim the oil or the water from the washer. You don't have waste oil in your plant either. You don't have any oil on your plant
Yeah.
floor.
Yeah.
These are some of the reasons that the larger captive shops have gone to the modular systems. Also, safety. There are no open flames. There are no risks of fire on the systems, as well as the fact that they're easier to maintain. In a fully operational, let's say 8 cell system for high production captive operation, it'll only take you about 5 hours to cool that whole system down if you had to go in and work on the whole thing.
Okay.
Whereas in a typical atmosphere high temperature furnace, it's going to take you 3 to 4 days sometimes to cool down and get in there. And it also takes time to heat it up again. In a modular system, it's about an hour and a half, and you're ready to start running. So that means now you can schedule your downtime on weekends, holidays. You don't have to have staff there to
Yeah.
run anything. You also don't have to have a secondary equipment like endo generators running
Okay.
to feed the carburizing gas. The carburizing gas is using acetylene out of cylinders.
Okay.
So it's not a regenerative system. It's not anything that you have to have a separate piece of equipment for to feed to the furnaces. So those are some of the reasons. And of course, the other one is capex expansion.
Okay.
So typically, these captive shops, they don't want to buy everything up front because their volumes are going to increase over the number of first few years. So in the beginning, they typically only have to have 1 or 2 cells ready to do a small amount of production so they can prove out the production and prove out the system. And then they can start building the system with more cells and more capacity later on. And typically, it's 2 to 3 days of downtime to add a cell to a system. So it's very convenient to do that. All of the utilities are typically along side of the modular system, so that you can easily add add a cell to it. Like I said, over a short period of time, and those cells can be ordered a year down the road, 2 years down the road,
Yeah.
whenever you might need that. You also can order peripheral equipment like extra temper ovens, additional automation. You can add robotics systems to the layout as well. So that's why captive shops are very interested in it. Also, workforce. It's a little bit easier to get someone to work on a system. As you can see, this one is
Yeah.
completely, clean and white. It's been in our Synergy Center here for 8 years. We use it every single day,
Hmm.
and it's just a very clean, aesthetic environment for anyone to want to work in, as well as they're water cooled. So that means not a lot
Okay.
of extra heat in the building around you to work in. So those are a lot of reasons. Sorry, but
Yeah,
those are
that's
a
all
lot of
right.
reasons
The more
for
reasons, the
anybody.
better,
Yeah,
right? More reasons, the better.
yeah.
How about on the commercial side? What commercial contract heat treat side? What would be the advantages here?
In the commercial heat treat side, it's typically because it's a very useful tool in itself.
Yeah.
So what happens is you can get multiple processes out of similar cells, and you can have a system that has an oil and a gas quench. So you can have a lot of flexibility in that one system that you have in the plant. I've visited hundreds of heat treaters, commercial heat treaters, and you have a number of furnaces on one area of the plant, a number of furnaces in another area of the plant. This actually gives you all the capability in one machine and one tool: oil quenching, gas quenching, FNC, nitriding, low pressure carburizing, carbonitriding, and neutral hardening, all in one piece of equipment.
You made reference to something I wanted to come back to, Dennis. You had mentioned about automation robotics. Can you talk about that in reference to like part fixturing and things of that sort? What's the if there seems like there might be advantages there?
Yes, absolutely. So that is also the new trend. Um, People that have modular systems are now looking at, okay, how do I automate the system to get make more production out of it? And what we're trying to do, or what we've been doing the last 5 years especially, is implementing systems that are using CFC fixtures. CFC fixtures are very robust in the furnace, but sensitive to being controlled outside. So what we try to do is to have the CFC fixtures be utilized in an automation that no humans have to interact with it. So we usually use robots for loading and external loaders and internal loaders to move the fixtures through the process. But it causes you to have a lighter load, which means less heating time,
Right.
less energy being consumed, and also the fixtures last 3 to 4 times longer if they're not damaged, of course.
Yeah.
But of course, all of these systems can be using regular alloy steel as well, and we can fixture different parts. You can use baskets. We are even now doing bulk loading where we have parts that are just filled into baskets and then processed, and we're doing that with vacuum carburizing as well, not just neutral hardening. So it's really interesting to see how the limits are being pushed, as well as the different materials that we're gas quenching now. I know 25 years ago, we were quenching some simple materials that were very high hardenability, and today we're quenching a lot of less hardenability steels.
Is that primarily due to increase of pressure in the quench, or is it something else?
It's pressure, it's flow, it's the intensity of the gas going through the parts. It's also heat removal as well. So heat exchangers removing the heat out of the load faster.
Out of the chamber.
We also have reversing gas quench motors as well. So we can reverse the flow inside
Okay.
from from top to bottom to bottom to top in the middle of the cycle.
Gotcha. Gotcha. Now we're going to have a quick video message from our sponsor, ECM USA. Okay, so some of the things you said also makes me think that these systems have a have something to say about sustainability and greenness. Would you agree?
Absolutely, especially when it comes to carburizing. These have been compared against typical atmosphere carburizing cycles, and the, only about 4% of the carburizing time is has gas injection, where we're actually injecting acetylene and having hydrocarbons being used in the process.
Right.
So if you consider that along with even if you took the same cycle time, 7 or 8 hours of a carburizing cycle, you're flowing endogas or whatever nitrogen methanol in the system for that full time. Whereas in a vacuum carburizing system, it's 4 to 5% of the time of the cycle that you're injecting it. So
Right.
ultimately, you only have about 10% of the CO2 output that you would have in a typical atmosphere furnace. And of course, I talked about the no oil in your plant either, so you're not reclaiming oil out of the water in the wash or off the floor or in your car when you drag it out of your heat treat shop.
Okay, so Dennis, the next thing I'd like to do is just talk through the process a little bit. In order to do so, I brought a video up on the screen that you've provided for us. I'd like you just to kind of describe the process here, right? Describe how the system works. So go ahead. This is our first screen here.
Yeah, sure. This is great. Thank you for pulling this up. So this is a plan view of one of our flex systems. In the center there, going left to right, is a tunnel section. This tunnel section is about an 8 foot diameter. It's tunnel,
Okay.
and it has a automated loader that moves down left to right or horizontally down through the tunnel, and it transfers loads from each cell to another in and out. On the bottom left is a loading unloading chamber, and in that loading unloading chamber, we remove the air once the load is put in there, and then we balance the vacuum on that cell to the tunnel's vacuum, and then we're capable of moving that load to an available heating cell, and that would be on the right of the system, the top right or the bottom right of the tunnel, those are heating cells, and you will then upload the recipe for that particular load into that cell.
Hmm.
While that load is processing, another load will be moving into the tunnel and into the other heating cell as well.
Gotcha.
On the top left is the gas quench cell,
Right.
which could be in this orientation or actually have an exit on the back as well. So here in this system, you could do neutral hardening, carbonitriding, LPC, a number of the processes that I indicated before.
Okay.
And this is really a very valuable tool, especially in a heat treat commercial heat treat shop.
Right. So I got a couple of questions just before we go to the next little section here. That obviously this whole unit is under vacuum, correct? I mean, the
Exactly.
from left to
Yep.
right, and all the four chambers that are attached to it. Okay, so you've got separation doors on at least on the entry chamber, right? You've got something where it can vacuum seal in
Yes.
this area, I'm assuming.
Yes, there are vacuum seals on the loading unloading chamber on the bottom left,
Yep.
and then the top left, the gas quench also has, of course, a seal
Right.
from a pressure standpoint. The two heating chambers are have just graphite door. We call it the flap door, and it just flaps, and it comes seals doesn't really seal actually against another face of graphite. So it's graphite to graphite,
Yeah.
and we're actually pulling vacuum out of there through the tunnel to create the central vacuum pressure in the system.
Okay.
We also pull vacuum from the cell itself, and we could also have a separate door on the front of the unit if the process is necessary to have that, or if we feel that a door is needed there by a customer.
Right.
So in a normal state or a standard unit, there are no hot seals on the door. Only a vacuum seals on the loading unloading chamber and the gas quench.
Gotcha, gotcha. And just to understand the schematic here, the plan view a little bit more. These are your vacuum pumps down here in the bottom right, I assume.
Exactly.
Okay.
Yep.
And
That's a process pump.
what
Yep.
what do we have up here?
On the top left, we have a gas quench tank.
Okay.
So what we want to know is we want to have enough gas uh, pressure and volume there to quench the
Yeah.
load quickly.
Okay.
It's very important to get the speed of the gas through the gas quench
Okay.
quick. So you're seeing the fact that we just added two more additional heating cells and a central tunnel section.
Right.
So basically, in essence, you just doubled the space, double the capacity of the unit, where you only added 50% of the space of what you had for capacity before. So
Right.
you're still utilizing the same gas quench, you're still utilizing the same loading unloading cell.
Right.
So you only added utilities for the two heating cells, not for a whole gas quench or oil quench capability there.
Gotcha.
And this can be added at a very short time.
Yeah. Gotcha. All right. Now I'm going to go to let this video roll here for a minute. There we go. We got through
So
another one.
what we did is we added another 50% capacity with two more heating cells and a tunnel section.
Got it.
Typically, what you want to do is to have the tunnel sized for about 5 years out for your capacity, and then buy the cells as you need them and have it grow.
Yeah.
So then the tunnel is ready to implement. So basically, we've just tripled the capacity of this installation, and we're only still usually using the same gas quench and the same loading unloading cell.
Right.
Typically, this system could go to 8 cells and have just one gas quench. So
Now,
that's a typical our orientation.
okay, and now I do notice on this one that it looks like we added maybe you just said this, Dennis, sorry, but it looks like we've added a discharge side here, right? Whereas before we were going, I think, in and out to both the same.
Yes. Mm-hmm.
Yep.
Yeah, it adds to the efficiency of the system
Right.
because the load is already in the gas quench when it's finishing.
Right.
So it just exit out the back. Yep.
Out the door. Okay. All right. Let's see what else we have here.
Okay, so now we have the loads entering, and the loads will go to the first cell that's available or empty, and then that recipe would be downloaded for that cell, and then the next load will go to the next available heating cell,
Right.
and download that recipe into that cell. So these could be two different loads. One could be for neutral hardening, one could be for carburizing. One could be for carburizing at a low case depth. The other one could be carburizing at a deeper case. In this case, of course, we just see the gas quench on here, but this tunnel could also be outfitted with an oil quench as well. And you could have one load go into gas quench, one load go into oil quench, or both go into either.
Right, right. So that gives people a sense of what the process looks like, and I was curious how that. I think that graphic really makes a lot of sense. All right, so now the tough questions for you. Are there any processes or materials that really it just doesn't make sense to process them through one of these systems?
Yeah, I would say right at this point, if you're doing a lot of annealing and normalizing, that's a longer cycle. There's some regulated cooling that's in there, so it's not really the type of equipment investment that you could make for that. If you were going to use it for a few loads in your plant, where you just maybe you got it from somebody that weren't annealed, or you wanted to try to anneal it for a particular process before you went to full production, you could certainly use it for that, but it's not a cost-effective methodology. As well as preheating that you mentioned,
Yeah,
wouldn't do preheating in the cell, but it is very flexible for a number of other processes, as we talked about. The other thing, of course, is the size of the part.
yeah.
These are typically 24 inches wide, and about 39 inches long and about 28 inches high. We do have a new system that will be the Flex Max, and it's a 1299 system. So it's a 3648 unit that
Okay.
comes with an oil quench, that's modular like this. We can either do an oil quench or slow cool cell on that system. So we will have that capability of 3648 in that modular system.
Yeah,
Um, yes.
yeah.
So those are some of the reasons. Those are some of the things. Other than that, restrictions on material, very few there. Like I said, you wouldn't want to do annealing and normalizing on a lot of parts,
Right.
but you could do it in these units.
Yeah, but based on the conversation we've had, it sounds like the sweet spot really is on the surface modification type applications, and
Yes.
maybe even some sintering is possible. All right, with dedicated
Yep.
chambers.
Sintering.
Yeah.
Yep.
Okay.
Brazing as well. Yeah. I didn't mention it, but
Bracing does
brazing,
work.
sintering, debinding. Yeah. Brazing as well. Yeah.
Okay. Okay. Yeah, that's good to know.
Can be done. Yeah. Can be done.
Aluminum brazing.
Not aluminum brazing, but some brazing applications, right?
Okay. Okay. All right. Fair enough. Okay. Last couple questions. CapEx. I think you already mentioned that you could potentially do some savings here for the amount you want to throughput by going one of these systems as opposed to single units that would do the same amount of work. Is there anything else you want to mention on the capital expense side of things? And then I got a question for you about operational expenses and maintenance expenses.
Great, great. As far as capital expenses to go, what the things that need to be considered is it's not a furnace to furnace comparison. Every time we go in, everybody just wants to know how much is your furnace. And the fact of the matter is that the companies have to take two steps back, look at your incoming material. How would you like to be able to modify that incoming material in your heat treat process to make sure that your outgoing quality is higher than it is today? And that's the kind of tool that a modular system gives you, or this type of modular system can give you, is give you a better quality part, also safety in your plant, a better quality work environment, being able to have the system off and safe in your plant and not have to have personnel around. So all of those things have to be considered when thinking about your capex expenditure and your investment, because looking at all of those items certainly is a much better situation than looking at a furnace to furnace replacement.
Yeah.
And that's really the methodology that people need to go through, to be able to understand the actual investment and what they're going to get for a value out of that.
Yeah. Yeah. And then operational expenses. I assume there's, like you said, you're only using single utilities, but what's your comments on about operational expenses of these units?
Yeah, operational expenses is if you, for instance, if you had a batch IQ sitting there, you typically keep it running whether you got load for it or not.
Right.
In this situation, you just shut off that cell.
Yeah.
You don't use it. You don't use it. It doesn't take any more energy. If you're working 5 days a week, you don't use it on the weekends. You shut it off. You don't use it during Christmas shutdown or any holiday shutdown, vacation shutdown. So you shut it off, and you're saving a lot of energy there. You're saving labor by having it off and nobody available to be there. Also, the opposite way, you could run it lights out if you wanted to as well.
Yeah.
So you could stock up a number of loads, 20 loads or whatever, on the automation before you leave. Have the system operate it, run it, have it come back out again before the morning. So, or you could have it time start as well. If you wanted to start it on Monday at 5 a.m., you don't need to be there till 8, but come in, the furnace is hot, ready to run process. So, a
Yeah.
number of operational advances over the typical operational heat treat that's out
Yeah.
there today.
And how about maintenance on this unit? The question that pops to my mind is, okay, let's say you've got, well, a couple questions pop to mind. Let's say your heating element goes bad in cell number 3. Do I have to shut the whole system down in order to fix that, or can I fix number 3 and leave the rest of the system up and running?
Yeah, so there are ways. So in this situation, you would typically shut off if you had a tunnel like we just showed you.
Yep.
You would typically shut off that cell
Right.
if you knew that heating element was out or it wasn't heating properly for you. You could shut off that cell, devalidate it, we call it, and then keep running the rest of the system until you had a window in your production that you could shut the whole system to get into that heating element.
Gotcha.
If you had a system where we had doors on the front, it could be possible to go in the back while the system is
Yep.
operating. Then it would be all based on your safety requirements or your plant and those kinds of things to
Right.
do that.
Right.
We do have another system called the Jumbo, and it is much more flexible in the maintenance world. It has a vacuum car that moves down on rails and docks and mates with every heating cell
Gotcha.
on the system. And in that line, the heating cell can actually be isolated from the rest of the line. You would just slide it back. It's on wheels. It slides back about 3 feet away from the line. You put in a new piece of safety fence, and you continue to run your line.
Yeah.
So you can completely lock out, tag out that cell, and work on it completely.
Yeah. Okay. Interesting. And then in the units, if you've got a vacuum leak, which
Mm-hmm.
happens,
Yep.
is that it? If it's a vacuum leak, the whole system is connected, right? So if you've got a vacuum leak, we got to stop and figure it out, right? I mean, it's not like you can. I think I have a vacuum leak in unit number 3. I can isolate it because if I remember correct, those are only graphite on graphite doors, correct?
Yep.
So if we got a vacuum leak,
Yeah.
we got to figure out where it is.
Yeah, most likely you want to
Shut it
fix
down.
the leak before you move on, especially if it's a bad leak. If
Yeah.
it's something
Yeah.
that's
Right.
that's causing you not to maintain your process pressure,
Right.
you certainly don't want to do that. Yeah,
Gotcha. Gotcha. Okay.
true, very true with every vacuum piece of equipment,
Well,
right?
that's exactly right. Yeah, you
Yeah.
got all of them. All of them are that way. Okay. Last thing. Tell me a little bit more about the. I think you said you've got 3 different models, right? And how many of these do you guys have? Does ECM actually have out in the marketplace? Let's say modular type systems.
So overall, modular type systems, the Flex is the most popular system that we just showed you.
Yeah.
We have a number of jumbos, and the unit I have behind me here is called a Nano, which has become more and more popular these days. And the Nano has 3 different size chambers, but they're typically smaller, 20 inch by 24 by 10 inch high size chamber. I explained a little bit about the Flex, and the Jumbo is the same. So out of those 3 systems, we have more than 350 systems. That's
Okay.
not just the heating cells,
Right.
but more than 350 systems that are out in the marketplace today, operating, running parts every day, running millions and millions of parts every week. And those are comprised of about 2,000 of the heating cells. So as much as people hear about this as being a new technology, it's really been around about 30 years.
Yeah.
And a lot of people have been using it and have replaced a number of pusher furnaces and those style furnaces for high capacity installations,
Okay.
especially.
Okay. Yeah, that's good. All right, Dennis. So that sounds good. I really appreciate your time. I want to thank all of the listeners and or viewers, if you're watching the video version, for taking some time to listen. And again, thank you, Dennis. And if you are interested in touching base with Dennis, if you're watching, his email will probably be up on the screen right about now. If not, you can always contact me. If you're just listening, you can contact me and I will put you in touch with Dennis. My email is doug@heattreattoday.com. So feel free to contact me and I'll put you in touch. Again, we would like to thank the sponsor of this episode, which is ECM USA. As you heard, they are the one, they manufacture these types of furnaces, and be more than happy to talk to you about those. You can find out more about ECM USA at ecm-usa.com on the web. If you like what you hear here on the Heat Treat Radio, we would very much covet your 5-star review on whatever platform you listen or watch. Believe it or not, even industrial podcasts like these, that actually helps us to get more and more popular. So we appreciate any type of reviews of that sort. And if you have a topic you would like for us to cover on a future episode of Heat Treat Radio, please feel free to let me know. Again, you can just send a note to me at doug@heattreattoday.com. That would be much appreciated. And this and every other episode of Heat Treat Radio is the sole property of Heat Treat Today and may not be reproduced in part or in whole without advance written permission from Heat Treat Today. Again, I'm your host, Doug Glenn. Thanks a lot for listening and or watching.